Imagine if you had to move something that was heavy. I mean, really heavy. How would you go about moving it? Well, you could start by eating lots of protein and lifting weights, which would take a really long time. Or you could recruit a bunch of friends to help you, but that requires knowing a lot of people, and they might not like you afterwards. Or you could do what engineers have been doing for a long time, and that's using something called mechanical advantage. What is mechanical advantage, and why is it so useful for solving everyday engineering problems? Previously, you learned about the 6 types of simple machines. These are really important to engineers because they give them something called mechanical advantage. Mechanical advantage is any time we use a machine to get more output of force than the force that we have to put in. You see, work equals force times distance. So mechanical advantage often increases distance to reduce force, the push or pull needed to accomplish a task. Think back to our heavy object. Imagine the difference between lifting it versus sliding it up a ramp. You've traded distance for a reduction of force. That's mechanical advantage. This is something that the ancient Egyptians understood well. They didn't have computers, electricity, but they were still able to build incredible structures. While nobody knows exactly how the pyramids were built, they no doubt used simple machines like ramps and pulleys to move large stones that formed the pyramids. They also used a plan and a design, and had to work as a team to create something new. That's engineering. When 2 or more simple machines are combined, they form what's called a compound machine. Take an example like a pair of scissors, which combines a lever and a wedge, or something like a fishing pole, which combines a wheel and axle as well as a pulley. Compound machines are all around us. Wheelbarrows, escalators, cranes, pencil sharpeners, corkscrews, and more. Anytime an engineer designs a compound machine, they need to balance efficiency with practicality. A bicycle is a great example of a practical and efficient compound machine. It can move you a far distance for a relatively little effort, much quicker than walking alone. An example of an impractical machine, one that does something simple in a very complicated way, is called a Rube Goldberg machine. Rube Goldberg was an American cartoonist who made cartoons showing these different types of complicated devices. Since then, the design of Rube Goldberg machines can be seen in movies, in games, as well as music videos. There are even competitions to see who can design the most clever and elaborate way of doing something simple in a very complicated way. So have you seen any examples like this, either in real life or in the media? Well, go ahead and share an example, like I did here, on our engineering Padlet.